Okay, so these equations we have here are ones that are similar to ones we did last week, maybe just a little more difficult, only because I used more difficult numbers. Let's take a look at the first one up here. So 5/8 x minus 3 3/4 equals 2.5. Now again, this looks complicated only because there's fractions in it. What would be the first step we would have to do here? You guys might have your mics muted on your end, so you may need to unmute them to answer. So the first thing we'll have to do is add the 3 3/4. So that would be gone. Adding 3 3/4 over here, 2.5 plus 3 3/4 is going to give us 6 1/4. So we now have 5/8 x equals 6 1/4. And then our final step to solve this would be to do what? We have to divide by the 5/8. So x equals 6 1/4 divided by 5/8. That's going to be we have to take this into an improper fraction. So 6 times 4 is 24, plus 1 is 25/4. And then multiply by the reciprocal of 5/8. So it's going to be 8 over 5. 25 and 5 cross cancel, give me 1 and 5. 4 and 8 cross cancel, giving me 1 and 2. So 5 times 2 is 10. X equals 10. Show of hands, how many of you had that? X equals 10. Okay, good. Anybody really confused as to how we got there that wants to see it done again? Or slowed down? Okay, perfect. Okay, I'm going to move this one down a little bit so we've got room to solve this next one. So on this one, we've got our decimals here. And we went over a couple of examples like this last Wednesday, where we saw there were 3 things that have been done to the variable. Because of this fraction bar, we know that everything on top happened first. So x was multiplied by the 0.7, then the 2.1 was subtracted. The last thing that was done was dividing by the 0.04, or by the 0.4. When we take it apart, that's the first piece we have to take off. So we divided by 0.4 to build the equation. We're going to multiply by 0.4 to get rid of that. So on the left side, all we've done is remove that dividing by 0.4. So we have 0.7x minus 2.1 equals 14 times 0.4 is going to be 5.6. Now we're going to add the 2.1. So 0.7x equals 7.7. And finally, we'll divide by the 0.7. So x equals 11. How many of you had x equals 11 for that one? Great. Finally, this last one. We did an example or two similar to this, but maybe not any quite this complex. Well, I know not any quite this complex. So let's take a look at it. I'm going to get the 3 out of here so it's out of our way. When we're dealing with one like this, about the only, I mean, we could change this into 1/15 times 4x plus 3 and negative 1/9 times 2x minus 3 and so forth. And we could do it out brute force with the fractions if we wanted to. There's a lot of room for error there. The other method we looked at for solving a question like this or a problem like this is to multiply by a common denominator to get rid of the fractions. So we've got 15, 9, 6, and 5. And we're looking for the least common denominator. Well, because 5 is a factor of 15 itself, I don't have to worry about the 5. So I'm just going to worry about the 15, 9, and 6. There are a lot of ways we could go about this. We make lists until we find a number that's in all 3 lists. I'm going to factor it. 15 factors to 3 times 5, 9 factors to 3 times 3, 6 factors to 2 times 3. Now when I'm looking for least common denominators, or what I'm looking for is really a least common multiple. And a least common multiple is going to be the smallest number to where all the factors are the same. So when they look at this, all of these numbers have a 3 as a factor. But there's leftover factors that we have to account for. For example, this top number, the 15, has a 5 for a factor that the other two do not. So I have to put a 5 in there as a factor for each of the other two. Now all 3 of those have 5 as a factor. The 9 has a second 3 that the other ones do not. So I have to put a second 3 in there as a factor for each of them. Now they all have a second 3. And the 6 has a 2 that the other ones do not. So I have to put a 2 in there. So looking at these, all of these now should multiply up to be the same number. 3 times 5 is 15, times 3 is 45, times 2 is 90. 3 times 3 is 9, times 5 is 45, times 2 is 90. And the bottom one multiplies up to 90 as well. So 90 is the least common denominator here. So to get rid of all my fractions, I could multiply this by 90. Okay, so we're going to multiply by the 90 here to get rid of the fractions. We have to multiply every piece here. So this one, and even on the other side of the equal sign has to be multiplied by the 90. So here I'm going to do 90 over 1 times my 4x plus 3 over 15. I can cross cancel my 90 and my 15, both divide by 15 to give me 1 and 6. So this just becomes 6 times 4x plus 3. 6 times 4x will be 24x. 6 times positive 3 is positive 18. This next piece is the tricky piece. This is 90. 90 is going to become 90 over 1, but this is actually a negative 1. The minus in front has to be accounted for. So it's negative 1 times that fraction. So it's going to be times negative 1 times the 2x minus 3 over 9. What I'm going to do is this. I'm going to combine the 90 and the negative 1. So this will be negative 90 over 1 times 2x minus 3 over 9. My negative 90 and my 9 will cross cancel to give me 1 and negative 10. So it'll be negative 10 times 2x minus 3. So negative 10 times 2x is negative 20x. Negative 10 times negative 3 is a positive 30. And that brings me to my equal sign. On the other side, I will have my 90 over 1 times 6x plus 4 over 6. So we've got the 90 divided by 6, or 90 across canceling with the 6. 6 divided by 6 is 1. 90 divided by 6 is 15. So it's 15 times 6x plus 1. 15 times 6x is 90x. 15 times 4 is 60. And then finally, we'll have the 90 times x over 5. So 90 over 1 times x over 5. Cross cancel the x and 9, or the 5 and 90, I should say. 5 divided by 5 is 1. 90 divided by 5 is 18. 18 times x is just 18x. So now down here we've got a lot of combining to do. 24x and negative 20x are going to give us 4x. 18 and 30 will give us 48. On the right side, 90x and 18x give us 108x. Then we've got positive 60 here. Now we still can't quite solve this because we've got an x on each side, so I've got to get rid of 1. I will get rid of the 4x. So right now I have 48 equals 104x plus 60. I will subtract 60. So 48 minus 60 is a negative 12 equals 104x. Now if I want this as a decimal, I'm going to be dividing by 104. If I want it as a decimal, I can just divide this out and get a decimal. If I want it as a fraction, remember we can treat division and fractions kind of interchangeably. So I just have x on the right side here. On the left, I can treat this as negative 12 over 104, both of which can be divided by 4, which will give me a negative 3 over 26. So x is a negative 3 over 26, or divided out as a decimal would be 0.1154. Of course, that's negative. Now you'll notice here, I moved the negative out in front of the fraction here instead of leaving it with the 3. Negative 3/26, of course, is negative. Negative 3 over 26 is the same value. It's still a negative divided by a positive, which is a negative. And I could even do 3 over negative 26. So when we have a fraction that's negative like this, we can either leave the negative out front, or we can apply the negative to the numerator or the denominator, as long as it's only one of them. We can't apply it to both. We cannot do negative 3 over negative 26, because a negative divided by a negative is just a positive. So that is not equivalent to these other three. But these three top ones here are equivalent to each other. Okay, so we solved those more complex equations. Next, we spent a lot of time talking about mixture problems. What I'm going to do is I'm going to put a mixture problem up here, and then I'm going to run down and see if we can figure out what's going on in Schwamigan there. Can you guys hear me now in Schwamigan? I'll give me a wave if you can. No, we're still not getting any volume there. Okay, so I'm going to put one up here for you to try. And then I'm going to go down and see if we can't fix that. So how much 47% solution would you mix with 240 milliliters of, what do I want to put here? 77% solution to create let's go with 65% solution. I'm going to have you guys try that in your notes. So what we're combining here, let's remember the first thing we have to do is figure out what we are mixing or what we're combining. We are going to mix 47 and 77% solutions. And we are trying to get a result that is 65% solution. The volume that we have, the amount, 240 milliliters, is with the 70% or 77% solution. And we're trying to figure out how much of the 47% solution we're going to need. And remember, these volumes are additive. So we're combining X milliliters with 240 milliliters. We better get X plus 240 milliliters in our resultant. So now our equation, it is concentration times volume. So 47 is 0.47 times the volume of X, plus 77% will be 0.77 times, I'll put up parentheses so it's easier, times 240 milliliters, equals 65% will be 0.65 times X plus 240. So we're going to go ahead and combine what we can here. We have 0.47x is just 0.47x plus 0.77 times 240 is 184.8. Over here, we've got 0.65 times x is 0.65x, and 0.65 times 240. 156. So we've combined what we can on each side. But we still have an x that appears twice, once on each side, so I'm going to get rid of the smaller one. So the 0.47x will go away. So what I'm left with here is 184.8. 0.65 minus 0.47 is 0.18x plus 156. Next, now we're ready to solve for x. Since we're down to the variable only appearing once, we're going to try to get it alone. So we're going to subtract the 156. So this is going to give us 28.8 equals 0.18x. And we shall divide by 0.18. So 28.8 divided by 0.18 will give us 160 equals x. So as always, we have to go back and see what x stands for and make sure that answers our question. So x here, which is 160 milliliters, is the amount of our 47%. And we are asking how much 47% would you mix? So that is what we're looking for, is 160 milliliters is the amount of the 47% solution we would use. So this next one, let's say that we have a cooling system for fever patients, for bringing down fever. Contains 200 fluid ounces of cooling solution. The system is supposed to be %40 ethylene glycol, but a test sample rates it at 28%. How much needs to be drained and replaced with pure ethylene glycol? I'm just going to put EC to reach the desired percent, to reach the 40%. So this one's a little bit different than what we've had before. We're going to mix. What's in the system already is 28%, so that's going to be part of the mix. We're going to mix pure ethylene glycol, which is 100%. And we want to get it up to a 40% solution. The volumes are where this one gets kind of tricky. It's a 200 fluid ounce system. We're not adding to it, we're draining out and replacing it, which means our result when we're done is going to be 200 fluid ounces. The system's going to stay the same. The amount that we're going to add of the pure ethylene glycol, or the 100%, is going to be X. So the amount of 28% is the full system, the 200, minus the amount we drained and replaced, so minus X. So now our formula, 28%, 0.28 times 200 minus X, plus 100% is just 1 times X, equals, where our result's going to be 40%, or 0.4 times 200. Now on each side, we'll do some simplifying. 0.28 times 200 is 56. 0.28 times negative x is a negative 0.28x plus 1x. Now we have things we can combine on this side, so I'm going to stay on this side here for a second and combine those. Negative 0.28x and positive 1x give me a positive 0.72x. And the 56 is still there, so it's 56 plus 0.72x. On the right side, we just have 0.4 times 200, which is 80. So now we go to solve this. We will subtract the 56. 0.72x equals 24. And now we'll divide by 0.72. So x equals 24 divided by 0.72. So 33 1/3. Just to make sure, that's asking how much do we need to drain and replace. And yes, it is 33 1/3 fluid ounces. Needs to be drained and replaced. Now I want to talk briefly about a bit more of an advanced topic in math. It's a step above what we need for this course, but this is a great application that could use it, and that's systems of equations. Now this will not be on your test, just so you know. But what we're really doing in a lot of these problems is a system of equations. We're just doing some steps when we set it up to kind of circumvent having to write out the system of equations. But let's say that we are going to mix 25% and 40% solutions to create 30%. Oh, let's do this. To create 300 milliliters of 30% solution. How much of each, now I'm referring to the 25 and 40% here, would we need to mix? So technically what's going on here, if we have 25% and 40% are the ones we're going to mix, trying to achieve 30% solution. We have two variables here if we're looking at the amounts. We could let the amount of 25% be x and the amount of the 40% be y. And we know that the total amount here is going to be 300 milliliters. So what we have there is an initial equation, x plus y equals 300 milliliters, where x is the amount of 25% and y is the amount of 40%. So then our second equation would be dealing with that solution. So the concentration of 0.25 times the amount of x plus the concentration of 0.4 for 40% times the amount of y equals our result of 30% times the 300 milliliters. And from here, to solve this system of equations, any of you who have had Algebra 2 have seen system of equations. We would take this equation here, x plus y equals 300, and we would solve it. I would solve it for y, or x, it really doesn't matter. Let's go ahead and solve it for x. I'm going to subtract y. So I get that x equals 300 minus y. So I'm going to replace x with 300 minus y. So 0.25 times 300 minus y plus 0.4y. That stays the same. I just replaced the x is all. equals 0.3 times 300. I'm going to go ahead and combine those. 0.3 times 300 is 90. And now we are back to the types of equations we were writing before. So I do realize that we are kind of taking some shortcuts when we're writing these equations to avoid dealing with two variables. But again, those of you that have had Algebra 2 and have dealt with systems of equations, that is what we're doing, is taking a system of equations and then reducing one of those or solving one of those equations so we can substitute it in so we only have to work with one variable. Like I said, that will not be on your test. Many of you, though, if you would go on to college in the medical fields, would be required to take a college algebra course. That would be something you would see. So I wanted to throw it out there to expose you to it. Very similar to these mixture problems, we have other types of mixtures rather than just solutions. I want to take just a brief look at investment problems. So an investment problem, the dollar amount of interest is equal to the rate times the principal times the time. Now, many of you probably have seen this as I equals PRT if you've done anything with investment or interest calculations. I adjusted it a little bit so that the rate is up front so it looks similar to what we have done with our solutions. The only thing is we have this added term of time on here. Well, for the first couple of problems, or the first problem we're going to look at, time is going to be 1 year, and time is always in years. So if I make it 1 year, the time is not going to be a factor in our problem. So let's look at this first problem here, and let's say Pat invests in a mixture of 6% and 10% investments. If Pat invested $10,000 and earned $900 in interest the first year, how much was invested at each rate? So it's the same thing. It's the interest from the 6% plus the interest from the 10% has to give us the total interest. So we have 6%. We don't know how much we invested there. So I'm going to call that 6% X. The 10%, we don't know how much we invested there, but we do know the total investment was $10,000. So we're going to let the amount of the 10% be 10,000 minus X. Since the time is 1 year, we don't have to include the time here. So we have 0.06 is our 6% times X, plus 10% is 0.1 times 10,000 minus X, equals our total interest of, now we know there's 10,000 invested, but we weren't given a rate. We were just told that the total interest was 900. So I'm going to plug 900 in there in place of that 10, the rate times the total. We could figure that out to be a 9% yield, but I just gave you the total amount of interest. So now to solve this, nothing happens with the 0.06x. We have to distribute the 0.1. 0.1 times 10,000 is 1,000. 0.1 times negative x is a negative 0.1x. So 0.06 and a negative 0.1 give me negative 0.04x. Plus 1,000 equals 900. And we will subtract 1,000. So negative 0.04x equals a negative 100. And we have to divide by the negative 0.04. So x equals $2,500. So again, we have to go back and make sure we answer the question. X is 2,500. That is the amount of the 6% investment. But we need to know how many are each of the investments. So 10,000 minus 2,500 equals 7,500. That's the amount of the 10% investment. So 2,500 was invested at 6%, 7,500 at 10%. Any questions? Okay, well, let's go ahead and we'll keep rolling here. I'm going to do one more example, then we'll hang her up for the day. Let's say Peyton invests $4,000 in a mixture of 5% and 8% investments. If the year-end, we'll stick with 1 year. Year-end yield is 7.25%. Again, how much was invested in each? So this one looks a little bit more like our solution problems. We have the 5% and the 8% that we are mixing, and the result is 7.25%. We know that the total invested was $4,000. That's going to go here. We don't know how much went for each. So I'm going to let X be the amount of 5%. The amount of 8% will be 4,000 minus X. So 0.05 times X plus this is 0.08 times 4,000 minus X equals over here 7.25% is 0.0725 times 4,000. So we'll simplify. The 0.05x won't change. We have to distribute the 0.08. So 0.08 times 4,000 is 320. 0.08 times negative x is a negative 0.08x equals 0.0725 times 4,000 is, I believe, 290. Let me double check that. Yep, 290. So then we can combine here 0.05 and negative 0.08 will be negative 0.03x. That's 320 equals 290. We're going to subtract 320. So negative 0.03x equals negative 30, and we divide by negative 0.03, which makes x $1,000. So again, back up here, 5% then was $1,000 invested. 4,000 minus 1,000 would be $3,000 invested at 8%. Okay, we're closing in on that time. There is no new homework for on Wednesday. Just make sure you have completed that page 53 to 54 on the mixtures, the 1 through 15. Hopefully on Wednesday we have our technical difficulties ironed out. Did you guys ever get volume at Schwamigan? Can you guys hear me now? Yeah. Okay, perfect. They figured out what was wrong? Yeah. Okay, is it just the TV set that isn't getting turned up, or?
I'm not sure.
Okay.
Well, I don't know. It's working now.
Okay. Well, hopefully we can keep her working for you. So on Wednesday, we're going to be back at full force. Everybody will be here. We'll be moving on with new material. And then it looks like after that, we don't have any days where anybody's gone until March 17th. So we'll have a few weeks of full strength there. So you guys have a great day, and we'll see you on Wednesday.